All right, logarithmic and exponential graphs. Logarithmic. Okay. Okay. I write it again right now. Today, 22. All right, so what are the key features, not functions? Of logarithmic and exponential graphs. Okay? Sir. You gotta speed it up. Zooming in. All right, let's talk about an asymptote. You've heard this word before, yes? Yes. Is it dotted line or a dashed line, whatever you want to call it? We can call it dashed. Dashed line. That the graph, my eyes blurry, gets close to, but never touches. It gets close to it, but it never touches it. Let's talk about exponential functions. You learned about exponentials in IM1. You refreshed your memory in IM2. We're going to do it again in IM3. It's f of x equals a times b to the x minus h plus k. A times b to the x minus h plus k. Your x minus h is your exponent, hence the word exponent in your exponential, right? So exponential means your x is in your exponent. this. Let's see, do we have... Okay. You have a horizontal asymptote. You have a horizontal asymptote, which means it's going like this. It's where you have y equals k. Your k determines your asymptote. Y equals k is a line. Okay? This is the equation of a line. Y equals 4 is a line. So it's our asymptote. If we have positive A, let's just pretend our asymptote is here. We have positive A. Looks like this. Remember? This is growth. We can also have a negative A. And this one's going to look like this. Now, in IM1 and IM2, you didn't do these. You did it this way, or you did it this way, right? We didn't really go this way or like this one, okay? We either went like this, or we went like this, okay? That's because we didn't really have a negative A. We just kept it always positive. So now you're going to have a negative, and what it does is it reflects it down. Do you see how it's reflecting down? So this is reflect up, and this is reflect down. But these are both for growth. Growth means that A is greater than 1. So for growth, your A is greater than 1. Can it be a negative number? Yes. But it's like 4, 2, 1.5, like 1.5. As long as A is greater than 1, whether it's negative or positive, you have growth. When you're between 0 and 1, whether you're negative or positive, then you have decay. Decay, when you have a positive A, you've seen before. It's what you do in IM1. Say it again. This one? This one? 0. 0. Is when it looks like this. You've done these, right? This looks familiar, and this should look familiar. Some of you may have done this one. We don't emphasize it, so I didn't do it. But you've seen these. Now we're going to add in the negative A's, so it's doing something different. I don't want that color. Okay. So these are our growth ones. These are our decay ones. This is when A is positive. This is when A is negative. This is reflect up. This is reflect down. Okay. Good. Let's talk about domain. What do you think your domain is? It doesn't matter your function. What do you think your domain is? If it goes either like this, or like this, or like this. What do you think domain is? Negative infinity to positive infinity. Good. Is the range going to be as easy? Yes or no? Do you think your range is negative infinity to positive infinity? Yes or no? I hear yes and I hear no. Why no? Why no? What's this thing here? The asymptote. Are you allowed to cross the asymptote? Are you even allowed to touch it? No, it gets really close to it, but it doesn't touch it. So therefore, this is my what? Has to do with my range, okay? So we're going to do 2. If we're going to have reflect up, when you reflect up, your range, so positive A, is k to infinity. Notice it's in parentheses. Your k is not a bracket. Why do you think it's not a bracket? Because it doesn't touch it, so you're not getting there. You're approaching it just like infinity, right? You can't really get there. Same thing. You're not touching it. And then reflect down. So negative A. What do you think that's going to be? If you're coming like this one. Negative infinity to 2? Good. I'm going to squeeze 2 things at the bottom, only because I don't want to go to the back and then use my paper there. All right, so we're going to squeeze 2 things in really quick. We did this already. What does it mean to be f of x? What does the number here mean? This is what? The whole thing is y, but what is just the inside? The inside is just x, right? The inside is just x. This means find y on the graph. We're going to do this together in a second, but I need to pass you out paper. This says f of x equals a number. Now this number here, what does the number represent? You said it the first time. This represents y. This means we have to find x on the graph. I'll show that in a second. Okay? I wanted to squeeze it in because what we're going to do is we're going to glue paper on the next page. You're going to get 2 pieces of paper. Listen very carefully. 1, 2. Keep both of them. Got it? So grab 2 and then pass. So you should have one with the title, and the next one should be number 5. And I don't know because I'm not counting, so I'm hoping that's enough between the 2. That should be, oh, sorry, plenty. I know that's extra, but you're grabbing 2. Remember, it's 1, 2, pass, 1, 2, pass. So you should have one with directions, and then you should have one without. One with directions and one without. There's extras out there. You got to get up and find them. I think T has a bunch of extras right there. We're going to do an exponential example, and then we'll do logs in a second. So what we're going to do is we're going to keep this whole page together. I'm just going to trim it up because I don't like the extra space in my notebook because I'm weird. Now, this is part of your homework, too, so I'll explain it in a second. So don't cut any of the problems, and don't cut the things at the top. So I'm just trimming it up. See, I left the top right there. And I'm going to go ahead and glue it to the back page. All right, so I just moved mine up towards closer to the top because I'm going to write something probably at the bottom, but I'm only going to do part of this problem, okay? So whatever we don't do in class is your homework. Do you understand? So you are going to have to write on a separate sheet of paper for some of it. And if you cut up the title like I did, like a oops mistake, it's key features of logs. So when you title your homework tonight, okay? You were probably wise to keep the title. I cut mine off. It's all right. Ready? We are going to do one of these. First of all, look at number 1. What do you notice about number 1? What kind is it? What kind of function is this? What? It is reflecting up. What kind of function is it? Do you know anything about a log yet? No, so it can't be a log. It's a what? It's an exponential. So we're going to go ahead and label that it's an exponential function. We good? Okay, I'm going to go ahead and answer most of this in the margin just because that's where it's going to kind of fit for me. All right, letter A says identify the intercepts and estimate if necessary. So let's label x-intercept. Is there an x-intercept? Is it going to ever touch the x-axis? No, there is none. Y-intercept. Where does it touch the y-intercept? How's that point? 0, 2. Domain and range. Well, first of all, we got to figure out where our asymptote is. Where do you think the asymptote is on here? So it's not a y-intercept. It's y equals what? Y equals 1. So we're going to say y equals 1. We're going to go ahead and color that in with our dotted line. And there we go. So we're going to say y equals 1 because our k is 1, right? We're pretty sure k is 1, so our y is 1. Okay, we need that for our range. Can we do domain? What is it? Negative infinity to positive infinity. Very good. Now the range. We needed that k for us to identify our range. What is your range? Is it 1 to infinity or negative infinity to 1? 1 to infinity. Because we're coming, there's nothing, we start at 1. It's your k. You keep going to infinity. All right.
Is no bracket?
We said that earlier. Why is it no bracket?
Because you don't touch it.
There you go. Okay, it says answer the specific question about the graph. We're going to answer the question, find f of 2. So we're going to go ahead and write f of 2 equals. Ready? Pay attention and watch, and then you can write it down. So what this says, remember this is f of x, correct? We're saying x is how much? It's 2. So we're going to go to the graph. You're going to go to your x-axis, which is to the right. You're going to go to 2, but I'm not going to stay here because that's not going to help me. I need to find where does it intersect the graph. And it intersects right here at this point. What is that number right there? You go this way to read it. It's a 5. So this is just 5. Okay? Did you understand that? So we said f of x, remember x is 2. You go to x2, find where it hits the graph. It's 5. Okay? Last, letter D, identify the asymptote. Oh, wait, we already did that, didn't we? So we can say the asymptote is y equals What is it? 1. It's kind of the first thing I did. Question?
You said it never touches, but when it starts, it's on the line.
It looks like it. It's not. If we were to zoom in super, super close, it would just be look near it. It always looks like it on these graphs. So it's going to look like it, but it doesn't. So when you graph it yourself tomorrow, because that's what tomorrow will be, you're just going to zoom as close as you can get, but just don't touch it. Okay? And if you send me a reminder, I can send you pictures of the worksheet. We good? My goal is to attach them to Google. You're all in Google Classroom, by the way. I added you all. You're welcome. Okay? We good there? Okay, let's talk about logs. So down at the bottom, I have room for a reason. I'm going to talk about logs before we do the next part of the worksheet. Okay? So let's talk about a log function. Logarithmic. Sir, we glued it into our notebook. Okay, let's write the function. It's going to say f of x equals a log of b x minus h plus k. Notice the b is small down at the bottom. You see it? Okay? So make sure you write a log b x minus h plus k. B is small down here at the bottom. Log should be easy to identify because it gives you the function what? Log. It tells you there is a log. Okay. The last one, exponentials had horizontal asymptotes. This one has a vertical asymptote. So if horizontal was y equals, vertical is what? I heard it. What is what? If this is y equals, this is going to be x equals. Good. But we're not going to equal k. We're going to equal h. Very good. So it's still a dashed line. But it's vertical. Okay. Oops, can't see that. Zoom out. There we go. All right. What do we know about this one? This one has positive a. Little sketch, and negative a. What's it, Raina? Because remember, that's your vertical shift. And the other one was your horizontal. That's why. So if you're positive, you're going to have some vertical asymptote. Then you're going to look like that. So it kind of looks like we took our exponential and turned it, right? Your negative a, still going to have a vertical asymptote. It's going to look like that. Anyone want to take a guess on domain? Could be one of two. Or really, it's only one. What do you think it is? Yes. Why? Well, yes, on the x-axis. Well, why is it h and not negative infinity? Because h is your what? Your asymptote, right? Nothing before it, then it starts, and then we keep going. Parentheses, because we're never going to what? You're never going to touch it. What do you think range is? Negative infinity, positive infinity. Good. Because we're going both directions up and down. Good. Okay. I'm going to go to the next page because I need to now put these ones in. turning the page. All right. Kaylin, you didn't get scissors? Oh, you have scissors. Okay. So the first thing you need to do in your homework tonight is you need to decide, do you have an exponential function or do you have a log? Okay? So that's going to be the hard part, is identifying if it's an exponential or if it's a log. What do you think 5 is? Oops. What's 5? How do you know it's a log? Well, I kind of want you to do a log, but why do we think it's a log? Where's our asymptote? That's probably the easiest way to identify first. First of all, if I'm looking here, is it kind of coming to a stop? A little bit, right? If I go this way, is it stopping? No. So where do you see the asymptote? X equals what? 0. So probably what I would do first is I would go through and identify the asymptotes first. It's probably the easiest way. Out of curiosity, what do you think 6 is? Log or exponential? Okay, good. All right, so we're going to do 5. We do know we have a log. We've already identified our asymptote. We're still going to follow the same directions. So the first direction was find x and y intercepts. Okay, find x-intercept. Is there an x-intercept? What is it? 1, 0, good. It's right here, yes? Okay, y-intercept. There's none, why? It's not going to touch it. We know our asymptote is at 0, so if we're never going to touch it, you can't have a y-intercept. So it's none. If my asymptote moved over, would I have a y-intercept? Yes, but for now I don't because it's on 0. All right, what's next? What's letter B? Domain? Domain and range? Okay. What's our domain? 1, positive infinity. Very good. What's our range? Good. Negative infinity to positive infinity. What's letter C ask? Answer it? Is that what it says? Yeah. Okay. All right. I want you to try this one by yourself. It says f of 7. I want you to figure out what you get for f of 7. F of 7. Talk to your partner. F of 7. Oh, yeah, you're right. Thanks. See? I was just writing what you guys said. You're right. 0. You're right. Sometimes I'm not thinking. What's your f of 7? What does it mean to be f of 7? What's 7? X, good. So we're going to go where x is 7, here, and we're going to go up. And we're going to go back here. Now you're estimating, or something really close. What do we get? 1.9. If you put 2, it's okay. You're really, really close, right? As long as you're relatively close. It's hard to see sometimes. Okay. If it's kind of a gap, then you can't put obviously the whole number, right? But this one's super, super close. It's almost hard to see. So like 1.9, 1.8, 2, somewhere similar. Letter D. What's it ask for? Your asymptote. Why do we change it to 0? Because it has to be your asymptote. So our asymptote was 0. So that's why it should be a 0. Make sense? Okay. On the other ones, remember it's your range, and that's why it's your asymptote again, because it's your range. And I just was writing and not thinking. I do that. What's next? X equals what? 0. Duh. Already wrote that. So, in reality, hold on. If it's easier, before you do domain and range, do letter D. Okay? I would go A and then do D first. Why? Or it's your asymptote. If you can figure out the asymptote first, then you can figure out your domain and range based on whether it's exponential or whether it's a log. Okay? So I would probably go from here to here, so now I know what I'm looking at. Does that make sense? Right, no question? You sure? Okay. Do you understand why I would do this first? We did it here. We highlighted it. But sometimes if we don't write it, like me, you write the wrong answers. So if I highlight it and then I write it, then I can go back and do domain and range, and then I know I have to use this number in domain or in range depending on which function it is. Okay? Make sense? Okay. So here's what's going to happen. Your job is the rest of them. Yes, they're glued into your notebook. You're answering it on what? Separate sheet of paper. Okay? You can fold it up into 8 boxes. You only have 8 questions. You really only have to do 6 because we just did 2. All right? So you're really only doing 6 problems. Now, you don't need to draw the picture unless you really want to. That's up to you. But you're allowed to go back in here and you're allowed to write on it like we did here. Okay? But if you want to draw it because that's easier for you, then draw it. If it makes more sense to draw it, then draw it. But you do have to label the top. So I know we cut it off, or maybe you didn't and were smart, unlike me. Then I would go ahead and label the top key features of logs and exponential. So you know when you turn it in, it has to have a title. Because if it's not titled, I don't know what it is, and then I forget. Questions? That was a lot of words from my mouth. We're good? As long as it looks very similar to 8 boxes. So you can draw it. But some people just draw like this big and then this big and then so then it's a hot mess. So as long as it's like the right amount of